Okay, so question 14, somebody had asked for a little bit of help with question 14. Now, study the following graphs. Now, let's have a look at the axes in the graphs. Each of them is a speed-time graph. So on the x-axis, we have time in seconds. On the y-axis, we have speed in meters per second. Now it says which graph shows in all or part of the graph constant speed. Now, constant speed means that the speed doesn't change. As the time goes on, you would represent constant speed with a straight line. Okay, velocity remains constant at whatever value that may be on the y-axis. Now, we have straight lines in a couple of the graphs to indicate that at these points we have constant speed. So, constant speed is a straight line. Which graph shows constant acceleration? So acceleration is the rate of change of velocity. So every second you're expecting to see the velocity increase. Okay, this would give you a diagonal line with a constant gradient. And we have two graphs here where we have that. So for constant, I'm just going to sketch this, acceleration, we would see a straight line with a gradient that doesn't change. Part C, negative acceleration. So every second that passes, the object or the car slows down. So let's have a look. We have a negative gradient here, a negative gradient here. So we can say that those two graphs exhibit an object slowing down. Other words for that, deceleration. An object with no acceleration. Okay, now if you have no acceleration, that means your speed does not change. And which of these graphs does your speed not change? Here, the speed doesn't change. You do see it in parts in the other two graphs, okay? You could say that in graph 3, the speed doesn't change for a certain period of the time, and also in graph 5, it doesn't change for a certain period of the time. This is represented by the straight line. An object at rest, okay, well, our objects are all moving, they all have velocity. None of them are on the time axis, everything has a velocity above 0. Object with the greatest acceleration, so remember the gradient of the line is equivalent to the acceleration, so you're looking for the steepest gradient, and the steepest gradient we can see, I'm just trying to move that out of the way, looks to me to be graph 5. Okay, so for graph 5, this gradient here, and remember the gradient is m is equal to y over x. It's the greatest change per second of velocity. Continuing varying acceleration. So if the acceleration changes every second, so 1 second it's accelerating by, let's say, 5 meters per second, then the next is 7, then it's 13, then it's 20, and it is not a constant. That would not give you a straight line. We're looking for a curved line, and of course we only have one graph with a curved line, our graph 5. So hopefully that gives you a little bit of help when you get to this question, and if you have anything else to ask, please post in Teams. Thanks.